So let's do the first one. I'm gonna ask you to work on this. Let me explain what we're gonna do for this one real quick. Okay. All right. So this example, a rock is launched vertically, okay, upward from the ground with a speed of 96 feet per second. Okay, neglecting air resistance. A well-known formula from physics states that the position of the rock after t seconds is given by the function s at t equals negative 16t squared plus 96t. The position s is measured in feet when s equals 0 corresponding to the ground. Okay, that's explanation of the content of the question. So based on this function, s at t, or the position that depends on the time t, goes with negative 16t squared plus 96t. So part A, we are going to find the average velocity of the rock between each pair of time. So you see the key term, each pair of time. So that means you have 2 points of time, and you are going to find the average velocity. As we saw earlier, the average velocity, how do we find it? We're going to find by using like 2 other pairs, right? The s at the position t1 minus s at position t0 divided by t1 minus t0. Just to make it easier, it's pretty much the same as y2 minus y1 over x2 minus x1. Okay, just use the notation based on its application as the function of the position. Okay, so for the first example, the first point of time would be 1, the second point of time is 2. To find the average velocity would be the s, or the position function, at 2, which is the second point of time here, minus s at 1, and divided by 2 minus 1. Okay, exactly the same as the slope formula that what we are going to do and use it to find the average velocity. Okay, and the same thing, the same way as the rest of them. So let me set up, and then I'll let you guys work on it. S at 1.5 minus S at 1 divided by 1.5 minus 1 for the second pair of time, and keep going the same way. Okay, keep going the same way. Do you guys have the calculator? Yes, I guess. Okay, let me finish this and then I'll let you know what I like you to do. The last one is different than the first 5 pairs because the the second point of time is not the actual number, is the expression like 1 plus h. The h is a notation to represent the difference between the first point and the second point of time. So we just keep going with the same notation provided. So the average velocity can be computed by s at 1 plus h minus s at 1, and all divided by 1 plus h minus 1. If you clean up a little bit, you would get s at 1 plus h minus s at 1 divided by, you see that 1 and 1 cancel. So the denominator is just in terms of h. All right, so this is the setup. So I already did for you guys. Now, what I would like you to do, you see each one of them, we're gonna need the function value s at 1. We need the function value s at 2, s at 1.5, s at 1.1, s at 1.01, s at 1.001, and the last expression will be s at 1 plus h. Okay, if you have the calculator, please help me find the function value first on the list on the left here. What are s at 1, s at 2, s at 1.5, and so forth. And I will check on you again in, let's see, in three minutes. you can type in the chat what the value that you found, okay? Oh, what happened here? If you don't have the calculator, you can use the web-based calculator to get the value out. Because I know it's very tedious, but this is a foundation, and we're gonna put them together to find to come up with the limit definition. And if you are not sure how to find the S function, you see the S goes by S at t is negative 16t squared plus 96t. So that means S at 1 is negative 16 of 1 squared plus 96 times 1. Okay, and you follow the same function to find S at 2, S at 1.5, and so forth. So anyone would like to share what values did you guys get? Let me make the bigger screen. Let's see. Yes, someone just came in, huh?
For the first one, I got 48, but I'm not sure if that's right.
The first one is 48. How did you, could you share how did you get that number? I can, oh, you mean the 48 for the average velocity or the S at 1?
For the average velocity.
Oh, okay. Yeah, the average velocity, yes, the correct answer is 48. Be, before we fill in the content here, could you share with me what do you get for each number that I listed on the left?
For
Let me see. For S at 1, what do you get?
80,
80. Okay. And S at 2?
128.
128. And then S at 1.5?
Oh, I didn't do the others. I just did the first one.
Okay, that's fine. That's fine. So basically, yeah, thank you. So the 48 is from S at 2, which is 128 minus 80 divided by the 2 minus 1. So therefore, you get 48. Okay, that's correct. Very good. All right. So we do the same as for the rest of them, but the reason that I list it on the left because it's going to be convenient for us to pick the number and put it in without like put too many numbers in or in the slot that in the average velocity column. So kind of try to manage in the easy way that we can track the work down in the case if we miss something. So that's the reason that I list on the left. So if you did not get the value or you already got the value, but you are not sure, so I'm gonna share what the value that I got. I just put in the case that I don't have the calculator, but I'm still have my computer that I'm working on. So I use let me copy and paste here. I use my Excel. So let me see. So you see my Excel spreadsheet. I just put in the two columns and the value T at one. So S at one gonna be 80, S at two is 128, S 1.5, 108, and so forth. And the way that you do as a normal way that you compute in Excel, negative 16, put equal sign, negative 16 times that cell value squared plus 96 times the same cell, and then copy the formula down. Okay, and you're gonna get the value that's listed on the right column.